So last time we finished until this part. Okay? We understand the underbidding and overbidding, and I guess you also have the problems about this underbidding and overbidding in your exam. I hope that you can understand the concept of underbidding and overbidding. So there are two methods to avoid overbidding. There are several ways. So I would like to explain only two ways. The first is static pull-out method, and the other is k-fold cross-validation. Static pull-out method. We got the static pull-out method because let's say we have our data set. This is the 100% data set. So among the data, we will split the 60% of the data will be used for the training, and then the 20% of the data we are going to put it as the validation data, and the remaining 20% we will use it for the holdout data. So the training set or the training data is the data used to build the candidate models. So we can use this data to fit with the model. We have another data, we call it validation set. This is the subset of the data to identify which model may be the most accurate in predicting observation that were not used to build the model. So we have our training data to build the model, and the validation data will be used to select which model is the best. So we can use like the accuracy, we can use the precision recall to check the model. And after we validate the model, we can test the model. And the testing set or the holdout data, it is used to validate the model performance during the training. It means we are going to estimate the model's effectiveness when applied to the data that have not been used to build or select the model. So in this case, we call this is the static holdout method because we separate the data statically. We select 60%, 20%, and another 20%. There is another approach, we call it k-fold cross validation. In the k-fold cross validation, the K means any number, integer number. So K can be 2, 3, 4, 5, any number. So let's suppose I have K equals to 5. So the whole data that I have here, so I can split it into 5 parts. So here, I can split it into 1, 2, 3, 4, 5. So the blue color will be used for the training set, and the remaining will be used for the test set. We call this is the iteration 1 or the first iteration. And when you did this performance, when you create the model with this data, we will check the error. And the next, we will go to the next iteration or iteration number 2. So this white is the testing set, and the remaining blue is the training set. And then at the end, we will get the error number 2. So we will do the next iteration, which is the iteration 3. So this is the testing, and then the remaining will be the training, and so on until we have the iteration number 5. So for every iteration, we will check the error, or we can check the accuracy. We can say this is the accuracy 1, and then we can have this accuracy 2. We can have the accuracy 3. We can have the accuracy 4, and we can have the accuracy 5. Okay. And if we have already all the accuracy, we can measure the average. So the average will be used. We can have this one, like this is the error. This is the average, 1 divided by 5. And we have the summation of the error. If we use accuracy, it means we can just do the summation of the accuracy, and then we divide with 5. So that will be the final accuracy measures. The other way, we call it lift one-off cross validation. So in the lift one-off cross validation, there are some terminology. We call it leave one subject out. If we have, there are many subjects. Okay? So let's say we have 10 respondents or 10 subjects. Yeah. So let's say this is 10 rows. Leave one subject out. So the first person will be used for the testing, and the remaining will be used for the training. So that will be the iteration 1. Next is the second person will be used for the testing, and the person number 1 and the remaining will be used for the training. That's the iteration number 2. Next is the person number 3 will be used for testing, and then the person number 1, number 2, and the remaining will be used for the training. So that's the iteration number 3. And so on until we have n iteration. Or maybe we have n minus 1 iteration, because one subject will be used for the testing. So we got this is leave one subject out. The idea is the same with this one, leave one sample out. So one sample means one row. If one row is eliminated, then we can use the same word as this subject. We can have leave one day out. So it means we can, let's say we have the sales from January 1st until 31st. So the day 1 will be used for the training. The day 1 will be used for the testing, and the day number 2 until 31st will be used for the training. That's the first. So the second, the day number 2 will be used for testing, and day number 1 and 3 until 31st will be used for training. And then the day number 3 will be used for testing. The day number 1 and 2, and then 4 until 31 will be used for the training, and so on. Okay. So we can say that one is the leave one day out. So one day will be excluded for the testing, and the remaining day will be used for the training. I think the graphical model will be something like this one. For the first, if we have a lot of data like this, so the first data will be used for testing, and the remaining will be used for the training. This and this brown color will be used for training, and this will be used for the testing, until we have the N model. So we can get the accuracy for every model generated. By using this k-fold cross-validation, at least we can avoid the off-fitting. Okay. I think you already learned these things, okay, in your mid-exam. You already know about the accuracy, what is accuracy and what is precision, and then what is recall, okay, and what is F1 score. So you can measure the F1 score with the formula you learn from the PowerPoint. So for basic model evaluation, how many data sets do we need to use? Yeah, how many? At least we have two. That is the training and testing. Okay. There are two types of partitionings. What are they? Explain briefly. So we have the first is static holdout method, and the other is k-fold cross validation. The static holdout method means we partition the data set into training, validation, and holdout. So the percentage can be different, but usually the training will be 60%, the validation will be about 20%, and the holdout is about 20%. In the cross validation, so we create partition with k parts. K is any number, integer number, and select one part as the testing and the remaining as the training set. Okay, so that's the brief explanation about the static holdout method and the k-fold cross validation. Okay, so let's go to orange. Okay, in the e-class, I already shared to you some data set, okay? Basic classification 1, and then basic classification 2, basic classification 1 with extension. Sorry, I guess they are the same. Okay? And I also shared the orange file, so let's check later for this one. So first, you can download the data set. The data set that we are going to use is the basic classification 01. This file is CSV. I think last time I explained to you that you can use the file or the CSV file import. If you use the CSV file import, it means you need to specify, let's say this is the CSV file. So you need to specify what is the separator. Here we have the cell delimiter. The cell delimiter means what is the separator between each of the value. Now I am using the comma. So when I use the comma, so the data is split clearly in the column. if I use tab, so if I use tab, then it seems it is not correct. So the data that you have in the CSV file is separated by comma, not by tab. That's why it is not correct. Or if you want to use semicolon, it's also not clear. If you use space, so something wrong as well. So the one is using comma. And yeah, you can make the code character. It means to define whether it is a string. And I know that some of you may use the data set from Korea. So maybe your data set contains some Korean character. So you can use the encoding. If you click this one, there are some encoding like the Korean character or Chinese character. Okay. Because orange is not from Korea, then there will be some issues with the Korean character. But maybe there will be no issue because if your computer is Korean, it will detect the Korean character easily. But if the data cannot see, if you cannot see the Korean character, you can use this Korean EUCKR encoding to make it clear. Yeah. So basically, file is enough. File is enough to open the data set. So you don't need to use the CSV. But in the case your CSV format requires more details definition, then you can use CSV format. Let me use file for this purpose. So this data is the same with the data that I explained in the PowerPoint. I can open the data table. We have the age, the age is less than equal 30, 31 under 40, we have higher than 40. And we have income, we have student, we have credit rating, we have the decision by computer. So if it is no, then the first person is not buying computer. If it is yes, then it means this person buys computer. We have another column, we call it balance and spending. Yeah, so I added these two columns. So balance means the amount of balance in the bank account of that particular person. And spending means the approximation of spending. Let's say this is the spending in 1 month. So we can look at the details. If you want to apply the distribution and etc., yeah, you can check the details. For now, I would like to just use the classification. In the classification, you need to select what columns that you want to use. So you can go to select columns. As you already learned from the classification part, most of the data that you use is the categorical data as the feature. So you can select what features are you going to use, and the most important thing is you need to select the target. You need to identify which attribute that is good for the target. And if you think that the attribute is not necessary, let's say, okay, I will just keep the balance. So you can remove it and you put it into the left part. So ignore means you will not use for the next analysis. Let's say the spending, you do not want to use it. So you can remove this one to the left part. So now we have four attributes: age, income, student, and credit rating. And the target is by computer. You can make the decision tree using tree widget. So you can look at the parameters here. The parameters include several things. The first is induced binary tree. Have you heard binary tree? Okay. In the classification, we learned one part about the binary tree. Okay. In this part, if the data is categorical and the categorical has many values, like color, like this one, red, green, blue, purple, orange, and etc. So every value can be in the branch. For example, income, you have the low, medium, and high. So it can be in the branch. But in the binary tree, you can just produce two branches. Yes, no. Or you can say we have the left and right. We call it binary, means we have only two options. So when you click in the orange with the binary tree, induced binary tree means you want to create only two branches, left and right. The next parameter is minimum number of instances in leaves. Minimum number of instances in leaf means if we have node and then we have another node and then we have another node and then we have another node. The node that have no other node, okay, the node that have no other branches, we call it is the leaf. So for example, this is the leaf, this is the leaf, this is leaf, this is the leaf. Minimum number of instances in leaf is 2. So at least there will be 2 instances in this leaf. 2, 2, 2. So we call this is the minimum number of instances that should be in the leaf. And the next parameter is do not split subsets smaller than 5. So if in the node there are more items or there are still 5 examples or 5 samples, then yeah, you can make another split. But if it is already 4 or less than 5, then just stop. You do not need to split anymore. Okay. So if it is 4, then you don't need to split anymore. Limit the maximal tree depth to 100. The tree can have the depth. So in this case, yeah, the tree depth is 1, 2, 3, 4. Okay, there are 4 depths. So we are going to limit the maximal tree to 100. So it means we can have until 100 depths. Stop when the majority reaches 95%. So when we have in the leaf, if the percentage is already 95, then we can stop. You don't need to split anymore. So you can look at the result in the tree viewer. So you can look at this one. Yes. What does it mean by yes? Okay. We know that our data is about buying computer. Yes and no. So the decision will be either yes or no. And here I know from the data that you learn in the PowerPoint, the number of yes is 9 out of 14 data. It means we have 64.3%. Okay, 64% is yes. So based on the parameter, if it is already 95%, yeah, you don't need to split. But here is still 64%. Then you can split. You can calculate. So based on the gain, the information gain or the Gini ratio or the Gini index, okay, the attribute H is the most important. So we will use H and then you will check. The first is 31 until 40. The last one is when the attribute H is less than equal 30 or it is higher than 40. So if you look at the right one, if the H is between 31 until 40, all answers are yes. It means all people who are in this age, they bought computer. Among 4 data, they bought computer. So we can see 100%. Yeah? So it means it is higher than 95%. Since it is higher than 95%, then stop. We don't need to split anymore. What about the left? When the age is less than 30 or higher than 40, we have 10 people, but 5 of them didn't buy computer. So it means another 5 is buying computer. 50%. Yeah, we can split one more time until we reach the parameter. What is the parameter? The parameter is stopped when the majority reaches 95 and also do not split subset smaller than 5 and also the minimum number of instances in the leaf is 2. So we will check how many numbers of the data here. Okay. Now we check again with the information gain or gain ratio or the Gini index. We get the attribute student is the most important. So we split. If the person is not a student, then okay, he didn't buy a computer. If he is a student, yes, he bought a computer. And the percentage is still 80%. This percentage is still 8%. Okay, because the percentage limit is 95% and the data is still 5, okay, then it means we can split one more time. So when we split one more time, okay, the most important attribute is 8. This one is higher than 40, then the decision is no. This one, if the H is less than equal 30, the answer is also no. For this one, the most important attribute is credit rating from this data. And then here we have the excellent. If the credit rating is excellent, the answer is no. If the credit rating is fair, the answer is yes. So if you look at this one, we have 50%. We have 50%. Can we split again? Can we split again? No. Yes. Yes. No. Yes. Or no? The answer is no. We cannot split. Why? Because we already put the parameter minimum number of instances in leaf is 2. So if you split again, then it means the minimum number in the leaf will be 1. Okay, so we will not split anymore. So this is the final decision tree. It's on the parameter that we already set before.